Hello guys, welcome to Gedika OER Peer Review Science channel. Today's discussion is going to be based on the logarithm. Otherwise known in short as the log, L-O-G. Now, in our discussion about the log, I'm going to rely on two things. We are going to rely on two things. Firstly, on peer review material, published material in scientific journals that gives us the definition of the log. We can rely on that definition because the paper itself, called The Birth of Logarithms, points to that definition. That definition can also be found in other sources, but I choose this material because it's peer reviewed, meaning there were other mathematicians who looked at it from different perspectives and accepted the paper, so we can accept it. About the law, it's called The Birth of Logarithms. The second thing we're going to rely on is actually foundation principles of mathematics. These are foundations that you see in arithmetic, counting, those foundations. So before I start, I just want to point out that in this channel, Gedika OER Peer Review Science channel, we rely on peer review material, primary material, that can give pointers to the evidence. The first evidence is given in this video on the same channel, The Origins of Mathematics, Black's Origin of Mathematics. This paper or this material is presented from a historical point of view to give you the history of mathematics, actually, how it originated and how it evolved. I would really recommend actually everyone to watch this video. You can treat it as a foundation, as a prerequisite to this material, but it's a prerequisite to the entire mathematics actually. And as you can see, it highlights what I call foundational principles, arithmetic, and you'll see how arithmetic itself connects to these guys. And in the middle, the same video provides what is called counting, pointing to the primary material. That's why you will appreciate the history of maths from an evidence point of view, how it all started and by who. You need to know your history. So these are the foundations of mathematics. Now, before I start, I want to point to this: the danger of a single story. If you taught your child, or if you ever thought yourself that, or you taught your child that 1 + 1 is 2, and so forth, meaning 2 + 2 is 4. know that you would have taught your child the Nazi style of teaching. That means at an early age, as early as you can remember, when you introduce the child to mathematics, you have already indoctrinated the child to thinking that the purpose of this, the sole purpose, is to come with an answer. Now that's a very huge, that's like, I've just dropped a bomb. And this is pertinent to elders, be it in the form of parent or educators, teachers, that is. I've got a paper here by Peter Oyo. Exploring students' proficiency in mathematical symbolization. In page 122 of this paper published 2022, it will be available to you on there. Peter Oyo discusses the meaning of symbols from a perspective of a learner. Exploring, he's exploring. Oh, there it is. And he asks two basic questions. One question he asks is, and as you can tell, and the second question is, and he discusses in particular the equal sign, the sign. Remember, the name of the paper is Exploring Students' Proficiency in Mathematical Symbolization. And he says here, the equality implied to others in his paper. I'm reading it, I'm not making things up. Others had the belief that it implied, it referring to this, that an answer was reached, R-E-A, did I say it right? Yes, reached, not R-I-C, R-E-A-C-H-E-D, reached, that you have arrived at an answer, that it implies that you have arrived at an answer. And in particular, that's how they see this symbol, according to this paper. That an answer, maybe let me write it down. That an answer, that an answer was reached, was reached. That's the meaning as they see of equality. So He gives these two things and he wants us, the student, the learner, to interpret. And this is what the interpretation is. It means this 2 plus 3, meaning it, the equal sign, as I read this paper. The equality, it means 2, that this 2 plus 3, this 2 plus, rather, let me start again, It means this 2 plus 3 equals or is the same as the answer you're going to get. Answer you're going to get, going to get, answer, going to get, answer, going to get. This, according to the paper, it means that the answer was reached. Now here there's no answer. And the child says, it's the answer you're going to get. And there must be an answer. And on this one, right, 2 plus 3 equals to 1 plus 4. Is that the sum of 2 plus 3, the sum? What does the student understand by the sum? Actually means the sign. I'm really impressed with this student. Not Peter Oyo, I'm talking about the student. That the sum for of 2 plus 3 and 1 plus 4, the sum of 2 plus 3 and 1 plus 4 are the same. Also making an inference that where's the answer? Hence the sum. He sees the sum as the answer. Meaning the sum of this is 5. The sum of this is 5. The sum of this is 5. He's saying that this equal sign means this sum, meaning 5, is the same as the sum of this, which is also 5. Is the student wrong or right? Is he correct? The inference is that, according to the paper, the equal sign always means that the answer was reached or was going to be reached or is reached. That is the danger of a single story. Where does the child get that? Where does this learner get that this sign means that? Who taught him that? If the child knows that this symbol means the sum, somebody must have taught him. Either the child is very, very, very good in English, like extremely good in English, for him to know the sum. It's as good as saying this symbol, which you call times or multiply, means product. Somebody must have told that child what to say. Now, that could either be a parent or an educator, or maybe even his counterparts, because they taught him from their parents' point of view and the teacher's point of view, or the internet, or something. If you are going to teach your child 1 plus 1 is equals to 2, which is correct, by the way. It is equals to 2. That's what I mean. But your method of teaching, it's Nazi. You are a Nazi. You are a Nazi style. You are teaching the Nazi style. And we are going to see using this concept of logarithms. So that's my introduction, right?